Hello friends, today we'll see few examples on equilibrium of concurrent forces. Actually these problems are very simple and we can solve very fastly also. So what we have to do when there is a problem of equilibrium of concurrent forces? First step is always you draw the free body diagram. So it's free body diagram you have to draw. Then in the second step, what you have to do? Either you use the equilibrium conditions. Which are the equilibrium conditions of the concurrent forces? Summation Fx equal to 0 and summation Fy is equal to 0. If we use these two conditions wisely, sometimes Fx may be earlier, sometimes Fy may be earlier. I'll explain when to use or which condition should be used first. Or if in few examples of concurrent forces, if only three forces are there, like this, if suppose 1, 2 and 3 concurrent forces are there, if suppose it is P1, it is P2 and it is P3, this is theta 1, it is theta 2 and then theta 3. What is the LAMI's theorem? P1 divided by sine theta 1 is equal to P2 divided by sine theta 2 and P3 divided by sine theta 3. So this is what the LAMI's theorem. But when we can use this LAMI's theorem, if only three concurrent forces are there and if its directions are either away from the common point or towards the common point, in that case only we will use this. Means by using only these two things, summation Fx, summation Fy is equal to 0 or LAMI's theorem. So I'll write over here LAMI's theorem. We can solve these problems. Now we'll see very first example of the concurrent equilibrium of concurrent forces. What is the example? Determine the tension developed in wire CA. CA means, so this point is C. This point is C. So it is C. Determine the tension developed in the wire CA, CB required for equilibrium of the 10 kg cylinder as shown in figure. Means this 10 kg cylinder is there. Because of this, there will be a tensions in the AC and BC cable. And we have to get this value. Then for that, first step in always the equilibrium problem is what? Draw the free body diagram. And how to draw the free body diagram of concurrent forces? I'll always suggest what you do. Any problem of concurrent forces, first you draw such plus sign. Always you draw such plus light sign. Then after that, what you have to do? See that the weight of the cylinder, how we have to mark that? It should be like this. From this point, the weight is acting like this and weight is going to be 10 kg, 10 into 9.81. So it is 98.1 Newton. Always force should be in Newton. So this is the weight from the common point. Then cut that CB cable and you show the tension. Tension means away from this. What is the angle? 40 degree. So this angle is 40 degree. And it is going to be TCB. It is TCB. Similarly, on this side, so this is going to be a tensile force. Cut this cable, this is going to be a tensile force and this force is going to be TCA and this angle is 30. Now, this is one of the best case of LAMI's theorem. Then how we can solve this example by LAMI's theorem? So you can write by LAMI's theorem by Lami's theorem. So first, always unknown forces TCA divided by sine of the angle between other two forces. Sine, so this is 90 plus 40, it is sine 130 is equal to TCB is equal to divided by sine 120 is equal to 98.1 divided by sine. So 180 minus 70 means 110. Sine 110. And whenever you are writing the Lami's theorem, what you have to do? First check the addition of these three angles, 130 plus 120 plus 110, it must be 360. Then our application of the Lami's theorem is correct. And in straight away in the next step, we can get the answer. This is TCA. Directly we can write TCA 98.1 by sine 110 into sine 130. So it is going to be 79.97. If you make this calculation neatly, we'll get this is TCA. It is one answer. And the second answer is what? TCB. For TCB, what we are supposed to do? 98.1 by sine 110 into sine 120, and it is going to be 90.41 Newton. Don't miss this unit. Finish. This is the solution of the problem of concurrent forces. Very simple example and easily we can solve. The most important thing, do not miss the unit. So that's all. This is the solution of this problem. Thank you. Now we'll solve the second problem on concurrent of forces. Concurrent equilibrium of concurrent forces. Three cables are joined at the junction C as shown in figure. Determine the tension in cable AC and BC caused by the weight of the 30 kg cylinder. So this is the sketch or figure of the problem. Then from this, what we have to do? So we have to draw the free body diagram. And for drawing the free body diagram, so the first step is what? Always draw the plus sign. Plus sign means horizontal line, vertical line. So it is the point of concurrency. Then after that, these forces we can show easily over here. So how we can show these forces? That we have to cut this cable and we have to show the tension in it. So this is the tension and that angle is 15 degree. And this tension is going to be 30, means 294.3 Newton. So it should be in Newton. 294.3 Newton, 30 kg. Then whatever this CA is there, so this point is C. So that's why CA, it is making 30 degree angle with vertical, means with horizontal, this angle is going to be 60 degree. It is going to be 60. And this is the tension in the cable away from C, and it is going to be TCA, tension in cable CA. Similarly, the inclination of this BC, if we cut it, so it is going to be 45. Means all these forces are meeting at a point, concurrent forces. So it is 45. And again it is going to be a tension away from the point. This is also one of the best case for using the Lami's theorem. It is the free body diagram. So this is free body diagram, which is the first step. Then after that, how we can use this? By using Lami's theorem. By using Lami's theorem. And for the Lami's theorem, always initially you write, so this is TCB, unknown forces, TCA divided by sine of the angle between other two forces. Other two forces means these two forces. 180 minus this 60 means that angle is going to be sine 120. is equal to TCB. Don't make the sketches complicated by writing all the angles over here. TCB, this force, angle between these two forces, 90 plus 15, 105 plus 30, 135. So it is sine 135. It is equal to known value 294.3 divided by sine 105, angle between other two forces. So this angle. So this is what the LABTECH theorem. Once again you check 135 plus 105, 240 plus 120 means LABTECH theorem, it is correct. And directly we can write the answer TCA and TCB from this LABTECH theorem. How we can write? 294.3 divided by sine 105 into sine 120. This answer is going to be 263.86. 263.86 Newton. So it is one answer. And second answer, how we have to make the calculations? Same, this ratio, known value into sine 135, and that is going to be 215.33 Newton. Finish. This is the answer. Means only statement and figure we feel that it's lengthy, but answer is very small. Don't miss writing the unit. That is very important. So it is the solution of this second example. And now we'll go for the third example on this concurrent forces. Determine the reactions at all the points of contacts for a sphere of 200 Newton kept in a trough as shown in figure. So see the sketch neatly, and then we have to draw its first step is, again as I told, it is going to be a free body diagram. It is going to be a free body diagram, and for drawing the free body diagram, always the requirement is what? So as I told, first draw the plus sign. So this sign. So it is very important, and if you draw like this, drawing this free body diagram is very, very simple. Then what we'll be doing? Now we have to make this sphere free from this contact surfaces. Means first in the free body diagram, draw the sphere. So this is what? The sphere. Means we have made this sphere free from all the contact surfaces. Then from that contact surface, actually what we have to do? So if this surface is making 35-degree angle with horizontal, then its reaction will make 90 minus that angle. Means angle made by the reaction over here, it is going to be like this. So this is going to be reaction, and this angle will be 90 minus 35. It is going to be 55 degree, and this reaction is going to be, let us consider this reaction is going to be, so at this point you can consider it is 1 and it is 2. Let's consider this is R1, reaction at this point. And then similarly, this surface is making 60-degree angle. Then what will be the angle of the reaction? It is going to be 30 degree. 90 minus that, it is going to be 30 degree. So let's consider it is reaction at point 2. And the weight of the cylinder we can show vertically downward, and again it will pass through this same point of concurrency, and it is going to be 200 Newton. 200 Newton. This is what the free body diagram. And once we draw the free body diagram, then problem becomes very, very, very simple. Then how we can solve this example? So three forces meeting at a point. The best way is what? Again, by using LABTECH theorem. By using LABTECH theorem. So unknown force first, R1 divided by sine of the angle between other two forces, sine 120. Sine 120 is equal to R2 divided by sine 145 divided is equal to known value 200 divided by, so this angle will be what? 60 plus 35, it is going to be 95. So this 60 plus 30, so it is going to be 95, sine 95. So this is what the LABTECH theorem. Then directly what we can do from this reaction at 1, R1, 200 divided by sine 95, 200 divided by sine 95 into sine 120, sine 120, will get the answer 173.87. So this is R1. Directly the calculations. And R2 will be what? R2 will be the same. This known ratio into sine 145, and this is going to be 115.15. You have to make the calculations neatly and make the calculation twice. Check it and then you go ahead. So these are the answer. Means like this, easily we can solve the problem of concurrent forces. So it is the solution of the third example on concurrent forces. And such type of one of the simple example is going to be there always in the mechanics paper. Thank you. Now we'll see the fourth example on equilibrium of concurrent forces. So here the question is what? A sphere weighing 1000 Newton is placed in a range as shown in figure. Find the reactions at the point of contacts. So let us consider this point of contact or A and B, or you can write 1 and 2. It per as per your wish. Then very first step is what? So very first step over here. It's drawing its free body diagram, and for the free body diagram again the requirement is what? When sphere is there, so always you draw the plus sign, and once we mark the plus sign, then after that what we have to do? Draw that sphere. This is the sphere, means we have made it free from the contact surfaces. And from the contact surface, from B, let's consider this reaction RB. And this will meet at this point. Means we can show directly like this. Then from this surface, it is making 45-degree angle. So we can show this reaction 45, and it is RA making 45-degree angle. And then third one is what? So it is going to be like this. Its weight we can show in this way, and that weight is given 1000 Newton. 1000 Newton. So this is what the free body diagram. And when free body diagram is there, three forces are there, the LABTECH theorem is the best option. But this problem can be solved by other ways also. So when to use that other way? If out of two unknowns, if one of the unknown is horizontal or vertical, then you can think directly summation fx is equal to 0 or summation fy is equal to 0. I'll show by both the way. So here if unknown is horizontal, then you use summation fy first. Summation fy is equal to 0. Now summation fy is what? RA sine 45. RA sine 45 minus 1000, it is equal to 0. So this is the summation of the forces in y direction is equal to 0. And if we make this calculation, directly we'll get the value of Ra. And that Ra value is what? 1000 by sine 45. Means we'll get this answer 1414.21 Newton. So this is the reaction at A. Then use the other condition. Summation Fx is equal to 0. These are the two equilibrium conditions for the concurrent forces. For summation Fx is equal to 0, what we'll get? Rb plus, it is towards right, minus, it is towards left. Ra means 1414.21 cos 45. Cos 45. It is equal to 0. Means Rb is equal to 1414.21 cos 45, and that value will get 1000 Newton. Finish. So simply by using the equilibrium conditions, we can solve the problem and we can get the answer. Other way of solving this example is what? Or I'll show the same problem by Lami's theorem. By Lami's theorem, because three forces are there again. Now Ra, unknown force, Ra divided by sine 90 is equal to Rb, again unknown value we have to take first, sine 135 is equal to the known value 1000 divided by this 90 plus 45, means again sine 135. Here calculations are very simple. From this directly we can write Ra and Rb value. For Rb value, denominator is same, means numerator must be same, 1000 Newton. And for Ra, if we make this calculation, sine 90 is 1, 1000 by sine 135, it is going to be 1414.21 Newton. Finish. This is the answer. And see, by both the way we get the same answer. You are having the choice of solving the example, but I'll suggest when out of two unknowns, one of the unknown is horizontal or vertical, then think of equilibrium conditions directly, and if both are inclined, Lami's theorem is the best option. So like this you can easily solve the problem of concurrent forces, and always you will find such one of the very simple example in your mechanics paper. Thank you.